Mathematicians, in this lesson you are going to learn how to place a fraction with a numerator of 1 on a number line by breaking the whole number 1 on the number line into smaller parts. You know that when we talk about fractions we are talking about equal parts of a whole. That means we are talking about one whole number being broken down into smaller equal parts. For example, if I get 1/3 of a pie, I am getting one piece out of a total of 3 equal pieces. That means that I am getting a piece that is bigger than 0 or bigger than none of the pie, but my piece is less than 1 or less than the whole pie. Fractions are parts of a number that are greater than 0 but less than 1. Here is a number line. We know that number lines show numbers in order as they move from smallest to largest. Each number has its own spot on the number line, which is usually shown with a tick mark. Each number's spot is equally spaced from the number before and after it. That's because each space represents the same amount. Let's say our unit that we are counting with is base 10 blocks. Each space between the tick mark would show or represent 1 unit block, like this. At 0 we would have no blocks, but the space between 0 and 1 would show 1 block. Then the space between 1 and 2 would show 1 more block, so that we have 2 unit blocks. And the space and the next space would show 3 unit blocks, and so on. If the whole number 1 has a spot on the number line that represents 1 unit block, and we know that a fraction is a part of a whole and is less than 1, if we break the space between 0 and 1 down into equal parts on the number line, we will be able to locate or find a fraction spot on the number line also. Let's say we want to find where the fraction 1/3 is located. In order to do this, first we would have to find the space between 0 and 1. We know that 1/3 is more than 0 but less than 1. So let's zoom in on just that space. All of the space between 0 and 1 are fractions of the number 1. I know that the denominator of any fraction tells me the total number of parts that the whole is broken into. If our whole is the number 1, we are breaking the number 1 into 3 equal parts. I could think of breaking the unit block into 3 equal parts, or I could break the space on the number line between 0 and 1 into 3 equal parts. We know that when we break something into 3 equal parts, we break it into thirds, like this. I could count each of these equal pieces by thirds: 1/3, 2/3, 3/3, or like this: 1/3, 2/3, 3/3. Now remember, I was trying to find the spot on the number line where 1/3 was located. I would look at the numerator, 1. The numerator tells me I'm thinking about just one part, so I'll shade in just one part. This is what it would look like if I were shading in just one part of the unit block. When I shade in just one space on the number line, it looks very similar. The spot where I land right here is the spot for 1/3 on the number line. This space right here is one of 3 equal spaces between 0 and the whole number 1. Let's see how this works in a problem. If we zoom back out onto the number line, we can follow the same steps to find 1/3 in relation to more whole numbers. The space between 0 and 1 gets split into 3 equal parts. I shade in one of those equal parts and label it as 1/3. Let's see how this works in a problem. Let's say we want to find where 1/4 is located on a number line. First, we would look at our number line to find the space between 0 and 1, because we know the fraction 1/4 is more than 0 but less than 1, and we would zoom in on that space. Then we would look at the denominator of our fraction, because we know that the denominator tells us the total number of equal parts into which our whole number is broken. It says 4, so we would need to break that space into 4 equal parts. If we break the block into 4, it looks like this. If we break the space on the number line into 4, it looks very similar. The numerator tells me I'm thinking about just one of those pieces, like this. So I would hop just one space from 0 to here. This spot is where 1/4 is located on the number line. This space right here shows or represents one part of 4 equal parts that the whole number 1 has been broken into. If I zoom out, I can follow the same steps to find 1/4 on the number line. The space between 0 and 1 gets broken into 4 equal parts. I shade in just one of those equal parts and label it as 1/4. Mathematicians, in this lesson you are going to learn how to place a fraction with numerators other than 1 on a number line by breaking the whole number 1 on the number line into smaller parts. You know that a fraction is a part of something, or part of a whole. So a fraction is going to be more than 0 but less than 1. For example, if you have a pie cut into thirds, one of those thirds is going to be more than 0, or none of the pie, but less than 1 whole pie. Let's start by looking at a number line. It is easy to see where all the whole numbers are, 1, 2, 3, and so on. Each whole number gets its own tick mark, and the space between each tick mark represents the same amount of space. We can think of each number being represented by base 10 blocks. Each space would show 1 block, like this. If we keep counting, it would look like this. Let's say that we want to find where the fraction 2/5 is located. We know that fractions tell us parts of a whole over the total of parts in that whole. So 2/5 is telling us that we are thinking about 2 parts out of 1 whole that has been broken into a total of 5 equal parts. That means that 2/5 has to be bigger than 0 but less than 1. So let's zoom in on just that space on the number line. All of the space between 0 and 1 are fractions of the number 1, or parts of the whole number 1. Since we are looking for 2/5, this fraction, we know by the denominator we need to break the space into 5 equal pieces. It would look like this if we're breaking a shape into 5 equal pieces. We do the exact same thing on the number line. The numerator tells us to think about 2/5, or 2 of those equal pieces. For the shape, it looks like this. For the number line, it looks very similar. 1/5, 2/5. This spot right here is where 2/5 is located on the number line. If we zoom out, we can follow the same process to see where 2/5 is in relation to more whole numbers. I would break the space between 0 and 1 into 5 equal parts and shade in 2 of those equal parts and mark my fraction. This space represents 2 equal parts out of a total of 5 that the whole number 1 has been broken into. Let's see how this works in a problem. Let's say that you want to find where the fraction 2 thirds is located on the number line. We know that 2/3 is going to be more than 0 but less than 1, so again we would zoom in to just that space between 0 and 1. The denominator tells us that our whole is broken into 3 equal parts, or thirds. If we do it with a base 10 block, it will look like this. If we do it on the number line with the whole number 1, it looks very similar. Now we check the numerator. The numerator tells us that we are thinking about 2 of those 3 equal pieces. The numerator tells us that we are thinking about 2 of those equal pieces. When we shade in 2 of those pieces on the base 10 block, it looks like this. On the number line, it looks very similar. 1/3, 2/3. This spot right here is where 2/3 is located on a number line. If we zoom out, we can follow the same steps to find out where 2/3 is in relation to more whole numbers. We take the space between 0 and 1 and break it into 3 equal parts. Then we would shade in 2 of those equal parts and mark our answer. This is the spot where 2/3 is located on the number line. It represents or shows 2 spaces. It represents or shows 2 equal parts out of a total of 3 equal parts that the whole number 1 has been broken into. Now you know how to place a fraction with numerators other than 1 on a number line by breaking the whole number 1 on the number line into smaller parts.
You already know that fractions have specific locations on the number line, and that you can find those locations by splitting the space between 0 and 1 into the number of equal-sized pieces it takes to make one whole. If I think about 3/4, I know that I need 4 pieces between the space of 0 and 1, or in one whole. And remember that I can do this by drawing a rectangle the exact size of the hole I want to place, and then splitting it into 4 equally sized pieces to mimic the space that the fourth lines will go on the number line. If I count over, I have 1/4, 2/4, 3/4, 4/4 is my one whole mark. That is how I place 3/4 on my number line. If I wanted to place a mixed number on the number line, such as 1 and 3/4, I can use what I know about placing regular fractions and add just one extra idea. With a mixed number, I have to be careful to identify where on the number line it will be placed, or between what 2 holes it will go. From previous lessons, you know that 1 and 3/4 means you have one hole and an extra 3/4 of another hole. This means this mixed number shows a value that is greater than 1 but less than 2. Knowing this tells me that I will need to place 1 and 3/4 somewhere between the hole of 1 and 2 on my number line. From there, I still know from the denominator of 4 that one hole will be composed of 4 pieces. I don't need to worry about this for the first hole between 0 and 1 because I know that the location is past the 1. Between 1 and 2, though, I still need to split this space into 4 equal-sized pieces to mimic where the lines on the number line will go, and again, I do that using a rectangle. That shows me where the fourths go on my number line. If I were to shade in 3/4 of this box, I would find the value of 3/4 and I would find the location that it mimics on the number line. Therefore, I can place 1 and 3/4 on the number line in this space where I ended my shading. Because improper fractions and mixed numbers can show the same values, it's important to be able to find the location of both on the number line. Let's do an example with the improper fraction 8/3 to make sure we can do this both ways. With an improper fraction, I know that my value is going to be greater than 1 because the numerator counts more pieces than there are in the one whole based on the denominator. But I don't automatically know how many holes I have. To figure it out, I can use my number line to help me. The 3 in my denominator of 8/3 tells me that there will be 3 pieces in each hole, and the 8 tells me I want to count over 8 third-sized pieces. Using rectangles just like before, I can split them over each hole into third-sized pieces and count over 8 until I get to 8/3. So in the first hole, I need 3 pieces. In the second hole, I need 3 pieces. And in the third hole, I need 3 pieces. And again, because my numerator is 8, I want to count over 8. And where my shading ends is the location of 8/3 on my number line. I can also double check this by making sure I have 1/3 all the way through 8/3 in evenly sized pieces. So 1/3, 2/3, 3/3, again at the location of 1 because 3/3 equals 1, 4/3, 5/3, 6/3 at 2, 7/3, and 8/3 I can see is placed correctly because it's 8 spaces over when I've split each whole into 3 equal sized pieces. Let's try this type of problem another way just to make sure we've got it. Sean was running on a track and wanted to know how far he ran when he finished. He noticed markers along the track and remembered that there was one marking the 1 mile point. If this was Sean's track and he stopped at the star, how far did he run? Here, I'm given a location on the number line and I need to figure out its value. Using what I already know, I can see that each whole is split into 5 pieces, and I can prove that by using that rectangle. If I look at where the markers are already split between the miles, I see that I have 1, 2, 3, 4, 5 pieces to make the first hole. That tells me that Sean's track was split into fifths of a mile. I also see that he ran a total of 7 fifth-sized pieces, 5, 6, 7. So Sean ran 7 fifths of a mile, or the star is at the location 7 fifths. I could also say that he ran 1 2/5 of a mile because Sean completed the entire first mile in the space between 0 and 1, and then he ran 1, 2 extra fifths in the second mile, so he ran 1 2/5. Now you know how to place mixed numbers and improper fractions.
Equivalent fractions, comparing fractions with different denominators. Value between 0 and 1. In this lesson, you will learn how to compare fractions with different denominators. How? You will plot the fractions on a number line. You know that fractions can be shown as part of a whole, part of a set, or on a number line as a value between 0 and 1. You know that the number on top of the line is called a numerator and stands for part of the whole. Each one of these examples, one part of the whole is shaded, so 1 becomes our numerator. You know that the number down below the line is the denominator, and that represents all the parts that make up the whole. Each of our examples here is made up of 4 equal parts, so 4 becomes our denominator. Each one of these examples shows the fraction 1/4. You know how to compare fractions when they share common denominators, or the denominators are the same. You can also compare fractions that do not have common denominators. Sometimes you can compare these fractions to benchmark fractions, like 1/4, 1/3, 1/2, or 3/4. In this lesson, you are going to learn how to compare fractions with different denominators, but from the same whole, on a number line. I'm going to explain this idea to you by showing you fractions on number lines. We are going to work with the fractions 2/3 and 3/8. While these fractions have different denominators, the wholes are equal. Each fraction is part of one whole. Each fraction shows a value between 0 and 1. This number line is going to show a value between 0 and 1. The whole is split into 3 equal parts. 1, 2, 3. That's why our denominator is 3. The numerator 2 tells us that 2 of the 3 sections are shaded in. 1, 2. So this now shows us 2/3. Here is the same whole, but now the fraction is 3/8, so our whole is divided into 8 equal parts, which is our denominator. Since our numerator is 3, 3 of those sections of the second number line should be shaded in. 1, 2, 3. When we compare the fractions on number lines next to each other like this, we can see that since more of the number line is shaded for 2/3, that fraction is greater than 3/8 and closer to 1. So we can say 2/3 is greater than 3/8. Let's see how this works in a problem. Which fraction is smaller, 1/8 or 1/3. Let's take a look at these fractions on number lines. Remember, each fraction represents a value between 0 and 1. We're working with the same whole, although the fractions are different. We can see here our two fractions plotted on number lines. The top fraction, 1/3, the number line, the value between 0 and 1, is split into 3 equal sections, and one part is shaded in. That represents 1/3. The bottom fraction, 1/8, shows that same value but divided into 8 equal parts, and one of those parts shaded in. Even though the numerators are the same, both the numerators are 1, you can see the fractions represent different amounts because the denominators are different. You can see that 1/8 is less than 1/3 because less of the value between 0 and 1 is shaded in. Remember, when the denominator is larger, the value will be divided into more sections, but those equal parts.
Each number has its own spot on the number line, which is usually shown with a tick mark. Each number's spot is equally spaced from the number before and after it. That's because each space represents the same amount. Let's say our unit that we are counting with is base 10 blocks. Each space between the tick mark would show or represent 1 unit block, like this. At 0, we would have no blocks, but the space between 0 and 1 would show 1 block. Then the space between 1 and 2 would show 1 more block, so that we have 2 unit blocks. And the space and the next space would show 3. Mathematicians, in this lesson you are going to learn how to place a fraction with a numerator of 1 on a number line by breaking the whole number 1 on the number line into smaller parts. You know that when we talk about fractions, we are talking about equal parts of a whole. That means we are talking about one whole number being broken down into smaller equal parts. For example, if I get 1/3 of a pie, I am getting one piece out of a total of 3 equal pieces. That means that I am getting a piece that is bigger than 0 or bigger than none of the pie, but my piece is less than 1 or less than the whole pie. Fractions are parts of a number that are greater than 0 but less than 1. Here is a number line. We know that number lines show numbers in order as they move from smallest to largest, 3 unit blocks, and so on. If the whole number 1 has a spot on the number line that represents 1 unit block, and we know that a fraction is a part of a whole and is less than 1, if we break the space between 0 and 1 down into equal parts on the number line, we will be able to locate or find a fraction spot on the number line also. Let's say we want to find where the fraction 1/3 is located.